So welcome to part 3 of lecture 3. So we've been talking about subspaces in today's lecture, and now what I want to do is take a bunch of these subspaces and kind of join them together to build bigger subspaces. So let's just kind of jump to the definition. So let's say we're given subspaces U1 through UM, and what we want to do is build the bigger subspaces. So what we're going to do is take a step back and just say, well, do you even need subspaces? Let's just take any subsets, take any sort of collections, subsets inside of your vector space V. And then the sum of the subsets, and it's denoted U1 plus U2 up to UM, is just simply the set that you get by taking an element U1 in the big set U1 and take an element U2 in the second set and so on, where you have little ui inside a big ui, and you take all possible sums, okay? And you take a collection of all such things, and that's called the sum of U1 through UM. So let me give you kind of a more concrete example to kind of visual. We'll do a picture in a second, and you may want to visualize f as being the real numbers here. But let's say that our vector space is F3, so we're looking at 3 tuples. U1 is the set of all things where the first coordinate can be anything, but the second and the third coordinate have to be 0. And U2 is the collection of all tuples where the first and second have to be 0, but the third element coordinate can be any element that I want. Well, then what would be the sum of these two spaces? Well, we have the definition right here, and the sum says you have to take anything in U1 and anything in U2, and you have to do all possible combinations, right? So it's anything that looks like x00 plus 00z, and this is equal to x0z, where x and z can float anywhere be any element inside of F. Okay, so that's the sum of these two sets, U1 and U2. So kind of just to visualize what's going on here, U1 is everything whose first coordinate can be any x and everything else has to be 0. So U1 is everything along this line right here. So this is U1. And U2 is everything where the third coordinate can be anything, but the first and second coordinates have to be 0. So that's everything along this line right here. So U2 is basically the z-axis and U1 is the y-axis. And now what we're doing here is we're taking the sum of all those guys, and notice that x and z can be anything it wants, but the second coordinate, the y-coordinate, has to be 0. So when we draw it, the sum is everything on this plane right here. Right? So hopefully you can see the picture. This is U1 plus U2. So that's the sum of these guys. And it's important to note that when you're taking the sum, so U1 plus U2, is that you usually get something that's a little bit bigger than just the union of those two sets, okay? Because the union of these two sets would be just the red line and the green line, but the sum of them is actually the blue plane, which contains the union, right? Because it contains the x-axis and the z-axis. So this is an example of a sum, and this is basically all I wanted to do in this short part, but the thing that I want to highlight is we've defined it for subsets, but question is now what happens if we also assume that we take subspaces? What are we building when we do this? And we already get a hint of what happens here is that U1 is a subspace, U2 is a subspace, and U1 plus U2 is also an example of a subspace. So we're going to make this a little bit clearer in the last part of today's lecture.